2007 Grade 9 Friar Math Contest. Squares measuring 1 by 1 are arranged to form the following sequence of rectangles. Many more rectangles are drawn, with each rectangle having one more row and two more columns than the previous rectangle. How many 1 by 1 squares would there be in a rectangle 4? Well, this is a 2 by 3, and I guess the next one is 3 by 5, and the next one is 4 by 7. So based on that pattern, the next one, which I guess is rectangle 4, would be 5 by 9, correct? 5 by 9, and they're asking how many of them. So if it's a 5 by 9, then there would be 45, right? 5 times 9 is 45. So there'd be 45 squares in rectangle 4. Determine the perimeter of rectangle 4. Okay, well, it's a 5 by 9, so if it's in the shape of a rectangle, this side is 5, this side is 9, this side is 9, and this side is 5. So the perimeter, obviously, would be 5 plus 9 plus 5 plus 9, which is 28. Determine the perimeter of rectangle 7. Okay, well, rectangle 7, let's just say rectangle 5, rectangle 6, rectangle 7. First, we have to figure out the dimensions. And the dimensions are basically based on the pattern. And that pattern is, following that pattern, rectangle 5 would be a 6 by 11. This would be a 7 by 13, and this would be an 8 by 15. Yeah. So if this is rectangle 7, this side is 8, this side is 15. So the perimeter would be 8 plus 15 plus 8 plus 15, and that looks to me like 46. And D, rectangle N has a perimeter of 178. Determine N. Explain how you got your answer. Okay, so this time they're saying that you have a rectangle, and this was rectangle 5, this was rectangle 6, this was rectangle 7, this is rectangle N. So we don't know. Is it the 10th one? Is it the 15th one? Is it the 50th one? We don't know. But we have to figure out the dimensions. Now, the dimensions, if you look at it, if you follow that pattern, it looks to me that this side is n plus 1. And I think if you compare, see, rectangle 5, this was a 6. Rectangle 6, this was a 7. Rectangle 7, this was an 8. So I'm pretty confident that that side is always n plus 1. Now this side, you think about it a little bit, and to me it looks like it's 2n plus 1. So when it was 5, it was 11. When it was 6, it was 13. When it was 7, it was 15. So when you just look at those numbers, it's not that difficult to figure out a pattern. So generally speaking, the sides are 2n plus 1 and n plus 1. So the perimeter would be n plus 1 plus 2n plus 1 plus n plus 1 plus 2n plus 1, correct? And that is, what is that? 1, 2, 3, 4, 5, 6. So 6n plus 4. And 6n plus 4, they are telling you, is 178. So there you go. There's the math equation that this question leads to. And then you just have to solve this. So this is 174 is 6n. And therefore n, I believe, is 29. And that completes number 1. At last week's hockey game involving the Waterloo Blueberries, the price of a platinum ticket was $25. The price of a gold ticket was $10. The price of a silver ticket was $5, and the price of a bronze ticket was $1. Jim buys 5 platinum tickets, 2 gold, 3 silver. Determine the average cost of the tickets that Jim buys. So 5 times platinum is how much? $25. Okay. Plus 2 times gold ticket, which is $10, plus 3 times the silver ticket, which is $5. And then, of course, you have to divide by the total number of tickets, which in this case are 5 plus 2 plus 3, which is 10. All right, so you crunch out these numbers, and you get 125 plus 20 plus 15, all divided by 10. And that looks to me like, what's that, 160 over 10? So that would be 16. So $16 is the average cost of the tickets that Jim buys. Part B. Mike buys 8 tickets whose average cost is 12. He then buys 5 more platinum tickets. What is the average cost of the tickets that he has bought? Okay. So same story. He buys 8 tickets and the average cost is 12. So that's the first part. And then he buys 5 more platinum tickets, and each platinum ticket is 25. And the average would be 8 plus 5, which is, the total number of tickets is 8 plus 5, which is 13. So here's the math. So that's what? 96 plus 125 divided by 13. And that's what? 221 divided by 13, which is 17. So $17 is the answer here. Ophelia buys 10 tickets with an average cost of 14. Suppose that she buys N more platinum tickets. The new average cost is 20. What is the value of N? Okay, so a little bit different. So this time she buys 10 tickets, and each is 14. And then she buys N of the platinum ones, and each is 25. And then the total is 10 plus N. And they've told me that that number would be 20. So I just have to solve this equation. So this is 140 plus 25N. And that is going to be 200 plus 20N. So this is 5N is equal to 60, and therefore N is 12. So that completes number 2. Question number 3. A number is divisible by 8 if the number formed by its last 3 digits is divisible by 8. For example, the number 47389 is divisible by 8 because 248 is divisible by 8. However, 47389 is not divisible by 8 because 284 is not divisible by 8. If 9924661A6 is divisible by 8, where A represents 1 digit, what are the possible values of A? All right. So we just have to concentrate on 1A6. If this is divisible by 8, then we're in business. So take out your calculator, because calculators are allowed on the Canadian exams, and just find multiples of 8. And then eventually try to get up to over 100. So the last one before 100, I believe, is 96. And then you just keep adding 8, and you get 104, 112, 120, 128, 136, 144, 152, 160, 168, 176, 184, 192, and then 200. So obviously we are only going to need to look at the ones that begin with the 1 and that are 3 digits. We don't need to go beyond this. And then the other good news is that we know that the last digit is a 6. So we only need to concentrate on the ones that have 6 as the units digit. And which one is that? So it's this one and this one. I think that's it, right? So those are the only ones. So therefore, the middle digit looks like the only possibilities are 3 and 7. So this 3 and this 7. And that's it. So that's your answer. Part B. Part B says, a number is divisible by 9 if the sum of its digits is divisible by 9. For example, 19836 is divisible by 9, but 19825 is not. If D767E89 is divisible by 9, where D and E each represent a single digit, what are the possible values of the sum D plus E? So according to the question, the sum of the digits must be divisible by 9. So the sum of the digits looks like, the sum of those numbers. So this will be D plus E, and then let's see, 7 plus 6 plus 7 plus 8 plus 9 is 37. Yeah. Okay, so where do I go from here? 17 plus 17 plus 20, 37. Okay. Well, I guess this has to be divisible by 9, so it's got to be obviously a multiple of 9. So what are the multiples of 9? Let's just write them on the side. Well, there's 9, 18, 27, 36. Now, these ones, obviously, we don't need to worry about because this sum here has got to be obviously greater than 37 because D and E are digits, positive digits, right? So let's see what happens then. 45, 54, 63, and so on. But even if these two were both 9s, the maximum you can get for that sum would be 9 plus 9 plus 37, which is what? 55, right? So we don't need to go beyond 55. So the only ones we really need to look at is 45 and 54. Okay, well, let's see what happens. If this sum, D plus E plus 37, is 45, then that means that D plus E is equal to 8. So that's one possible answer to what they're asking. If the sum was 54, then 54 is equal to D plus E plus 37, and therefore D plus E is going to be 17. And that's it. I really don't think there's any other options here. So 8 and 17 are your only possible values for D plus E. And then moving right along to part C of this question. The number 541G 507 286 is divisible by 72 if G and H each represent a single digit. What pairs of values of G and H are possible? Okay. All right. Okay, well, the good news in this question is that they've helped you out with part A and part B of this question, right? Because this number now is divisible by 72. But what is 72? 72 is equal to, last time I checked, 8 times 9. So if a number is divisible by 72, it's also divisible by 8, and it's also divisible by 9. And in part A of this question, you were told that a number is divisible by 8 if the last 3 digits are divisible by 8. So in this case, that means 2H6 is divisible by 8. And then part B of this question told you that a number is divisible by 9 if the sum of its digits are divisible by 9. So that means that all of these guys added together, which is 5 plus 4 plus 1 plus G plus 5 plus 7 plus 2 plus H plus 6, that entire sum, which I believe is 30 plus G plus H, is divisible by 9. So we have to, I guess, try to figure out those two things, and then whatever we figure out, we have to combine it. So let's start. I guess I'm going to start with this guy here. That seems to be the simpler one. So let's see. So very similar to part A. I'm going to write down all the numbers that are multiples of 8, and I guess the largest one is 192 before we get to 200, right? Because we really only have to concentrate on ones that begin with 2, 3-digit numbers that begin with 2. And then we get into 200, 208, and so on. 216, 224, 232, 240, 248, 256, 264, 272, 280, 288, and finally 296. And then the next one would be 304, but we don't need to worry about that guy because that's over 200. And then as before, we have to look at ones that have a unit digit of 6. So that would be this guy and this one. Any others? Yeah, the very last one. Okay, great. So that means that this H can be either 1, 5, or a 9. All right, so that's good. So then now we can move back to this guy here. We have a few possibilities now. If H is equal to 1, then this becomes 30 plus G plus 1, which is 31 plus G. Now this has to be divisible by 9. Okay, so let's look at multiples of 9. We have 9, 18, 27, 36, 45, 54, and let's just stop there. I don't think we need to go any higher. 31 plus G. Well, if 31 plus G is equal to 36, then that would mean G is equal to 5. If 31 plus G is equal to 45, G would be 14, and that's not possible because G represents a single number. So there we go. We just got our first one. I'll just list them here. Our first combination of G and H is 5 and 1. Right? So we just going here. So we keep going here. So we took care of that one. And then now we do h equals 5, and that means 30 plus g plus 5 this time. That would be 35 plus g is some multiple of 9. We look at those multiples of 9, and it looks to me like in this case, g is a 1, right? Because if it was equal to 45, g would have to be 10, and that's not possible because g is just a single digit. So in this case, g is equal to 1 when we set it equal to 36. Yeah, 36. I gotta make sure here, do it right. Okay, so there I got another combination of 1 and 5 this time. So that takes care of this guy. Now let's take care of the 9. So when h is 9, that means we have 30 plus g plus 9 this time. So that's 39 plus g. And looks to me that that could probably only equal 45. And in that case, g is 6. So we have 6 and 9. So that takes care of this one. And these are therefore the 3 possible values, the 3 possible pairs of values. In the diagram, triangle XYZ is right angled at x, with yx equal to 60 and xz equal to 80. W is on a point on yz, so that wx is perpendicular to yz. Determine the length of yz. WZ, sorry. Okay, well, this one, there's several ways of doing this, but I'm just going to go with Pythagoras. 60 squared plus 80 squared is equal to yz squared, and that's directly from the Pythagorean theorem. And when you solve this, very simple, you'll get 100. So that means from y to z, that entire distance is 100. Okay, not sure if that helps, but let's just keep going here. Now we're going to have to do similar triangles. Let's just label some angles first. So if this is theta, that's 90 degrees at x, the angle at x. So this would be 90 minus theta. And similarly, since the angle right here is 90, this angle in here would be 90 minus theta. So there you go. You got a similar triangle situation. That triangle XYZ is similar to triangle WXZ. And therefore, the relationship can be created by using the sides. For example, WZ over XZ is the same as XZ over YZ, right? Because WZ represents the 90 theta side on the triangle on the triangle WXZ, and XZ XZ represents the 90 theta side on triangle XYZ. And then similarly, XZ here represents on the triangle WXY the 90 minus theta side, and YZ represents the 90 minus theta side on triangle XYZ. So that's just how similar triangles are done. And now you just sub in the values if we have any. We have WZ, we have XZ as 80. And then YZ, I believe we have as 100. So then solve this. And when you solve that, you get WZ is equal to 80 squared over 100. And that is 64. So there you go. 64 is the answer to this question. Five points, A, B, C, D, and O lie on a flat field. A is directly north of O, B is directly west of O, C is directly south of O, and D is directly east of O. The distance between C and D is 140. A hot air balloon is positioned in the air at C. As positioned at H, directly above O. The balloon is held in place by 4 ropes. Rope HC has a length of 150 and HD has a length of 130. Determine how high the balloon is above the field. All right. So we got a little bit of information here. So we have HB, which is this rope. Then we have HA, which is this rope. Then we have HC, which is that rope, and then finally HD, that rope. And we have to figure out what is the height, HO, right? How high is the balloon above the field? HOOH. So OH is what we have to figure out. Okay, so the first thing we're going to do is do some labeling here, because we're going to probably have to use Pythagoras a few times. Now, they've given us some information that rope HC is 150. So put that 150 right there. And 150. And then rope HD, that's 130. Okay. So let's see, where do we go from here? And then I'm going to label this distance from C to O. I'm going to label that A. And then from O to D, I'm going to label that B. And then we'll have two Pythagorean relationships. Since that is a right angle and that is a right angle, we're going to have OH squared plus B squared is equal to 130 squared. Right? That's this relationship right there. And then this relationship, that would give me that OH squared plus A squared is equal to 150 squared. Okay, that's pretty useful. And then, but there's a lot of variables here that we don't know. OH, A, B, and A. But the good news is that I think they gave us one more hint. Yeah, this one right here. That hint is very important, because they're saying that the distance from C to D is 140. So that helps tremendously, because now we can combine A squared plus B squared is equal to 140 squared, since this is also a right angle in there. This angle would be a right angle. Okay, so I think I have to combine these guys. This is going to be 2 times OH squared plus A squared plus B squared is equal to 130 squared plus 150 squared. And the good news here is this is 140 squared. So there you go. We just got rid of 2 variables. I'll just substitute 140 squared. And then now you just have to crunch out these numbers. And when you do, I'm sure you can do that, so I'll let you do it. And when you do, you'll get a final value of OH squared is equal to 9900, and therefore OH is the root of that. And if you put it in, mixed radical, it'll be 30 root 11. So there you go. That takes care of part B. And now we move on to part C of this question. Part C. To reduce the total length of the rope used, rope H and rope HC and HD are to be replaced by a single rope HP, where P is a point on the straight line between C and D. Determine the greatest length of rope that can be saved. Okay, so I think I will need to have this diagram in the photo. So basically what they're saying is that there's some place on the line between C and D that you're going to put P. So I don't know where. Let's just say it's here. So that's P. And then they're going to draw one rope like that instead of a rope from H to C and H to D. And they're saying, how can you do that so that the distance between HP is minimized, and therefore using the least amount of rope? Okay. So what I'm going to do is that triangle HCD, I'm going to draw flat on this part here, like that. And HC was 150, and HD was 130. So it's not perfectly drawn to scale, but you guys get the idea. And then P is somewhere on that line between C and D. Now, we want to minimize, our goal is to minimize HP, right? So the way to do that is to draw a straight line down, right? The shortest distance between 2 points, I guess, is a straight line that's perpendicular. So let me just draw a straight line here, and then we'll talk about it. So it would be straight down like that. That would be the shortest distance from H to the line CD. And I think that is pretty much the heart of that question. Once you kind of figure that out, everything else falls into place. Yeah. Okay, let's go with this. CD we know. The full length from C to D is 140. That was given in the question. But C to P I don't know, so I'm just going to call it X. And then P to D I don't know, so that's going to be 140 minus X. And then, since this was perpendicular, I think we have two Pythagorean relationships again. So, off we go with Pythagorean theorem. Nothing really fancy. So in the first triangle, HCP, it would be 150 squared is equal to X squared plus HP squared. Yeah. And then, sorry, this is, 150. It looks like a 6 for some reason. And then very similarly, in the other triangle, we'd have a very similar Pythagorean relationship, and that triangle is HPD, and that one would give me that 130 squared is equal to 140 minus X squared plus HP squared. All right, and I think at this point we can just use those two and solve for X. So if you subtract these two equations, you get 150 squared minus 130 squared on that side. On this side, you get H squared minus 140 minus X squared, and the HP's cancel. So since the HP's cancel, that's the only variable left is X, so therefore we can solve for X. So off we go. So this, if we crunch out the numbers here, is 5600. This one, you kind of have to do a little bit of algebra here. So this is going to be 19600 minus 280X plus X squared. And then this is 5600, and I believe the X squareds cancel, so the only thing that's left is 280X minus 19600. Put everything on one side and solve for X, and you'll get X equal to 90. And therefore, we can, I guess, go back into any of these and calculate HP. So let's just plug it back into the first one. So that's going to be 90 squared plus HP squared. And when you crunch out these numbers, you'll get HP is equal to 120. So that means that before, our rope was HC and HD, right? And HC, if I remember or recall, well, it's right here actually in our diagram, 150, and HD is 130. So before we had 280 meters of rope. Now we have just HP, and that's 120. So if you compare, we went from 280 to 120, so that means we saved 280 minus 120, which is 160 meters of rope. And that completes part C of number 4.